Let's talk about exponents. If we see something that looks like a to the n, okay, where a is some value, it's also referred to as the base, and n is an integer, okay, it can be positive, so here we're talking about in terms of natural numbers, but as we'll see in a moment, it can also be negative, and n can also be 0, and as we'll see in the next document, n could also be fractions. But let's start off with the case where we have an integer or a natural number. When we see a to the n, what it means is that a multiplies itself n times. And if we see a to the 0, we get 1. Anything to the power of 0 is 1. And if we say a to the negative 1, it just means 1 over a to the n, and then the bottom a is multiplied out n times, whatever that n may be. So let's look at a couple quick examples. So remember, anything to the power of 0, this is always going to be 1. When we say 3 to the negative 2, let's put this into a form that's a little bit easier to work with. So I'm going to go 1 over 3 squared, and that gets rid of my negative, and this is going to give me 1 over 9. Now, when we have to the negative 1, we can get rid of that negative by going 1 over whatever we have. And by the properties that we looked at the other day, this is the same as going 1 times, and then you flip that fraction, so 3 over 2. So this value here would just be 3 over 2. You don't have to show the work that I just wrote out here. Whenever you see a fraction to the negative 1, you can just flip it right away. All right, now we're going to look at the properties of exponents. For those of you who aren't familiar with this notation, this fancy z just means integers, so negative 1, 0, 1, 2, negative 2, and r just means real numbers. Okay, so if we have real numbers a and b, but this m and n, these are integer values, if we have the same base and we multiply out an expression that looks like this, it's the same as taking our base and then adding up our exponents. If we have division, where we also have the same base, so we have a and a here, this is going to be the same as saying m minus n. In the case where we have a to the m in brackets, and then that whole thing is multiplied by n times, this is the same as saying a m times n. And similarly, if we have, if we have these brackets here, and we have m, a and b both get multiplied out m times. So we can think about the m as distributing into the a and b. Same thing with the division here. We can just distribute our m. Okay, now let's say that we have these brackets around a, we have to the power of n, but what happens if we have a minus? That n does get distributed into the minus 1, and depending if n is odd or even, we'll get different values. So if you think about, for instance, negative 1 squared, that's positive 1. If you take negative 1 to the 4, that's also positive. But if we take this to the power of 3 or to the power of 5, there's an odd number of negative 1s, so we would get a negative value. Okay, so hence these rules right here. All right, now let's do a couple of problems where we simplify our expression here. So I have 2 to the 2 times 2 to the 3. So you could write the second term, 1 over 2 to the 3 if you wanted to, but we can just use the multiplication rule because we're allowed to do this with integers. I can just say 2 plus the value I have is negative 3. So I have 2 to the negative 1, and this is just 1/2. Similarly here, it's probably going to be easiest to first split up this rational expression into 2 terms. So we can write it as x cubed over x plus x to the negative 2 over x. And then we can do the same rules, the division rules. So I can go x3, and I have 1x on the bottom. And even though I have negative exponents here, I'm going to do the same rule, and then I'll just simplify it afterward. So I have negative 2, and then I have minus 1. This is going to give me x squared plus x to the power of negative 3. I want to have positive exponents, so to get rid of that negative, I'm just going to go 1 over x3. All right, let's do another one. Now let's do one with multiplication. We're going to have to distribute this 3 here. So the 2 is going to get multiplied out 3 times, and the x squared will also get multiplied out 3 times. Okay, so 2 to the 3, or 2 times 2 times 2, that's going to be 8. And then I have y 2 times 3. So I'm going to get 8 y to the power of 6. For this next question, we're going to distribute the 5 into the top term and the bottom term. Okay, so we can think about this as x squared to the power of 5, and then y3 to the power of 5. And then we have x 2 times 5, and then I have y 3 times 5. So I'm going to get x to the 10 over y to the power of 15. For this next one, before we start simplifying, there's a few different ways you can do this, but what I'm personally going to do is, because these are all multiplied together on the top and the bottom, I'm just going to bring this a down here and this b up here. So if I do that, I'll be dealing with positive exponents. So b to the 7, b to the 5, divided by a to the 4, and I'm going to bring that a to the negative 3 down to get rid of the negative. And then by multiplication of the same bases, I can just add these up. So I'll end up getting b12 because of the 7 plus 5, and then a to the power of 7 because of the 4 plus 3. Okay, great. Now for this next one, I'm going to rewrite these in order to get rid of my negatives. So I'm going to write this as 1 over x plus 1 over y. And I want to combine these terms, but I need to have a common denominator. So for the first term, I'm going to multiply the top and the bottom by a y. And the second term, I'm going to multiply the top and bottom by an x. So if I combine them with the same denominator, I'm going to have this over xy. And then on the top, I'm going to have a y plus an x. Finally, let's do this one. I'm going to do a similar thing for my denominator and my numerator. So the first thing I'm going to do is the top part, I want to get rid of those negative exponents. So I'm going to write 1 over x squared minus 1 over y squared. And then to make sure I don't get confused, I'm going to put a big line here. And my denominator, I'm going to get 1 over x minus 1 over y. Now, even though this looks a little bit weird, don't let it freak you out. I'm going to first find a common denominator for the terms in the numerator. So I'm going to make all of those adjustments in the numerator, and then I'm going to make adjustments in the denominator, work with them separately, and then I'll worry about this big divides here. Okay, so I'm going to need an x squared y squared as the denominator of this part here. So the first term, I'm going to have to go y squared over y squared, and then I'll go x squared over x squared. And then for this term here, I need to go y and x and x. And then x and x. So what do I have now? So my new numerator, I'll zoom in a little bit here, is going to be y squared minus x squared. And then this is going to be divided by x squared, y squared. So that's my top. I'm going to put a big line here to make sure I don't get confused. And then I'm going to go y minus x all over x times y. All right. Now, so what did we just have? We had our y squared minus x squared over x squared y squared. But because those terms are being divided, I can bring up the denominator and then flip the ordering. So I can go x, y over y minus x. Okay, and remember why that is. If you have a over b divided by c over d, by our division rules, this is the same as a over b dot d over c. And now I can simplify this a little bit. I can simplify my xy here to get rid of one of the x's and y's in that first term. And also notice that this is a difference of squares. So what I can do is I can factor it. I can have a y minus an x and a y plus an x. That gets rid of the cross terms. I always want to say crosshairs, I'm sorry. And then I have y and x left over here. I have a 1 up there, and then a y minus x here. And I can cancel out one of these y minus x terms, and I'm left with y plus x over xy, and then this second term is just 1 over 1. So my solution is y plus x over xy. And there we go.